Hey everyone, welcome to my new TF2 modeling tutorial for the Steam Workshop. Since my last tutorial over 2 years ago, the process of getting 3D models into TF2 has changed. This change is due to the new way models are compiled, and thus the modeling and texturing portions of my last tutorial are still relevant. This tutorial will mainly focus in the new process of compiling, and so I'm going to not put too much effort into explaining the fine details of modeling and texturing, and if you would like to get a lot more detail on that, you can check out my last tutorial, which covers a lot of that stuff. Before continuing, I did decide to put together my old tutorial from the Steam forums onto Steam as a Steam guide, and it's sort of like an archive, and it basically just goes over everything the old-fashioned way, including all the frequently asked questions and stuff from the old Steam thread. And this is just in case anyone ever wants to take a look at it again and refer back to it. As you guys probably know, TF2 had an update, the new Steam Pipe update, and it was a different format, file format for Valve to use. It basically increases, it decreases loading times. It has new file setups and stuff like that. It basically just makes it easier for the users and Valve to work with files on both ends. And because of this, they've also added a beta importer to the to Team Fortress 2. And what that'll do is that changes the compiling process a little bit. So I'm going to go over that. One important thing to note is that since we're using a new compiler, it doesn't actually support weapons yet. So it supports hats and miscellaneous items. But because of the fact that we can't add extra SMD files, which is the file format that of models and animations, there's problems with physics models and the like, and so weapons aren't supported yet. But I'm sure in the near future Valve will add support for weapons. And go figure, most of my workshop entries are weapons. So without further ado, I'm going to explain the programs you need for this tutorial. All of these links will be in the video description, and I will show an overview, a list of all the programs in just a second here. So first of all, you're going to need Blender, obviously, or any 3D modeling program will work, as long as you have a way to export and import SMD files. I use Blender because it's free, it's open source, and it's good for TF2 modeling and Dota 2 modeling. I love it. So I'm going to be using 2.62, version 2.62, but you guys can download the latest version, doesn't matter. I recommend downloading the zip file, not the installer. So definitely, so if your operating system is 32 bits or 64 bits, choose the appropriate version, download the zip and extract it. You'll also need Blender SMD tools. This is the plugin for Blender, which you will need to import and export SMD files. And SMD files are basically Valve's model and animation files. So this is the model type that we'll be using in this tutorial, and basically throughout all source games. Another program you'll need is GCFscape. This allows you to extract GCFs, or in the new Steam Pipe Beta VPKs, from your client-side files. So basically, we'll be extracting player models so we can actually use the rig when we're applying bones when we're applying our models to bones. And the last program you'll need is MDLdecompiler, and this is what once we extract the models from the VPKs with GCFscape, we'll use MDLdecompiler to decompile them into SMDs, which we can then import into Blender. So I recommend using Hooch's fixed version of MDLdecompiler. This makes it so you don't have to change IDST0 to IDST, like I explained in my last tutorial. So make sure you download Hooch's fixed version. This link will be in the video description. And you also need Photoshop or Paint.net or GIMP or something basically to edit textures and stuff like that. So I use Photoshop. But I think I haven't used GIMP personally, but I hear it works just as well. So if whatever floats your boat, Photoshop is my favorite image editing program, so I use that. So now that you have, so once you have all your programs, we can begin. So just but as a quick review, here are the list of required programs. Blender with the SMD Tools plugin, Photoshop as I mentioned, GCFscape, which is used to extract things from the VPK files, and MDLdecompiler, which we use to decompile the extracted models. And Team Fortress 2, obviously we need that for the beta importer. Okay, so the first thing we're going to do is we're going to create these input and output folders just like in my last tutorial, and again these are for staying organized. So in our input folder, that's going to be our compiled models that we're going to use to decompile them. So I am going to be making an engineer hat for this tutorial, so I'm going to need the engineer player model. So how do I do that? Well, open up GCFscape and click Open. Navigate to your program files, Steam apps, your comment folder, Team Fortress 2, TF, and down here you'll see a bunch of VPK files. Okay, so the one we want to open up is this one right here. It says TF2 underscore miscellaneous C underscore directory. So TF2 underscore MISC underscore DIR. Open that up, and you'll see a bunch of files in here. So we're going to find the engineer player model. So go to Models, Player, and then find engineer. So all the ones that say engineer, select all of these, whoops, and drag them into your input folder. So we have that. Now we can close out GCFscape since we don't need this anymore. Okay, so now we're going to use the fixed version of MDLdecompiler to decompile our model into an SMD. So the MDL is the compiled model. We're going to turn it into an SMD. So so go to your input folder, select engineer, the one that we just extracted. That's our MDL file. And we're going to select our output folder that we created as the output folder. Okay, so extract. Alright, until you complete a dumping model, you can exit out of that. So now if we open up our output folder, we'll see that it created a bunch of SMD files. All of these are SMD files, and it created one QC file, which in the old tutorial we used, but in this one we will not. So now the challenge here is trying to figure out which one of these corresponds to the engineer model. So a lot of these are sort of like bogus models that we don't need, so we're going to have to try to figure out which one is the one we need. Usually it's a large file, so something like 2000 or 2 megabytes or something like that. So this is probably the one we want. You can mess around with this just to see if it's the actual file or not. So if you go ahead and open up Blender, we're going to start a fresh scene here. We're going to just delete everything in the scene, including the light. Sometimes if you want to preview your model, the colors might not show up right if your lights are not placed properly. And if you don't have any lights at all, like I just deleted the light, then it'll just make everything full bright, which is okay for purposes of Blender since you're not really rendering anything. So I'm going to go to File, Import, down here, Source Engine SMD. So for newer versions of Blender, this might be a little bit different, but the main point is that we want to find the SMD file. So find where you can import SMD files right here, select it, go to wherever your file was located, so output, and we're going to select this one is the one I thought I said, engineer morphs low.dmx.smd. So you're going to, and this is actually important. So for some reason Blender defaults to the Z up axis. We're going to change this to the Y up axis. This makes it a lot easier for rotating the camera, and it corresponds with how Valve sets up their models, pretty much everyone else. So it's the Y up axis. So make sure that's selected. Select engineer morphs low.dmx.smd and then import that in. Okay, and if it worked properly, you'll see we have our engineer model. He's missing an arm, but that's okay. Not important. The most important part is the fact that we have the rig, which is this skeleton-looking thing. These are the bones, and as you can imagine, the part that animates in game is actually the bone structure, this rig. And by applying certain vertices of this model to different parts of the bone, we can have the vertices move in the direction of the bone. So you can imagine that when we create a hat, we will want to assign the hat to one of these bones such that the hat will move with the character's head. Now in most cases this will be the BIP head bone, BIP underscore head. So we're going to show that name. So if you'll notice here, this is the BIP head bone. In other tutorials, sometimes you might need to use a different bone. Like for example, the engineer had a helmet as a default item. With the new importer system, I think it disables the current hat, so you don't have to use the PRP helmet bone. Just for safe bet though, we'll just use the BIP head bone for this importer. And if you want to texture this guy, just so you can see it textured, you can also use GCFscape to bring out a texture from the VBKs. Okay, so now I'm going to explain how to bring in your hat or start from scratch and model out this hat. So let's see. So I already have a hat made. I'm just going to import this in. But before I do that, I guess I could explain a little bit of some of the quirks of this. So remember, Shift A creates mesh. You can create like a cylinder or whatever you want. We can turn this to 16 vertices. Bring this up here. You can start by creating a hat here. I'm not going to go too much in the details. Remember, my old video explains all of this in detail. Tab switches from edit mode to object mode and back and forth. A selects all the vertices. R rotates. S sizes up and down. G moves around, etc. And another important tool is the B box grabs, and E extrudes, etc. And then you can mess around with these controls down here. Instead of selecting vertices, you can select faces. You can make it so that you can't see through faces, which is nice if you are having a hard time with so many different vertices and whatnot. C tool allows you to face select with this circle. Anything it touches, it selects. And so yeah, so I already have a hat created. I'm going to import it now. So let's see here. Perfect. Okay. So this is a hat I made for the engineer. It's kind of a goofy looking hat. My inspiration was from Little Nemo in Slumberland, if any of you are fans of that. And you'll notice that there are some things that might be that could be changed about this. Like for instance, everything is currently smooth shaded. So let me explain shading real quick. You have two different types of shading. There's smooth and flat shading. This is flat shading, where it shows each individual face shaded distinctly from one another. And smooth shading makes it so that the light sort of is smoothly applied to each face and doesn't individually mark out a face. So this is what you're going to want to use. But on hard models, you want to add smoothing groups. And in Blender, we call these edge loops. So in order to do that, you want to select your model, go to Modifiers, and choose Edge Split. Edge Split, yes. And for the purposes of this tutorial, it's probably better to choose an edge angle. And what this does is any angle with a degree of any angle that is above 30 degrees, and you can specify this number, will apply a distinct smoothing group to this. So basically, for instance, this edge right here, as you can see, it's like a 90-degree edge. It's a straight up face, and it goes straight out like that. So that's 90 degrees. So you don't want to make that smooth, or else it'll look kind of weird. So here, let me show you how it looks like without. See, you can't define an edge like that. So basically, if it since this angle is above 30 degrees, it creates a hard edge there. So anywhere you see angles that are above 30 degrees, it'll create hard edges. So around the sides here, and etc. So you can like change this. You can change this number up and down just to see the effect that it has. 30 degrees is okay, so we'll leave it like that. If you want to manually mark sharp edges, so let's say I'm not really happy with this. I want to do it manually. You can go into edit mode, and I'm going to change these to quads real quick. Tries to quads, so I can work with this much easier. Let's say I want to change this edge. I want to make that sharp, so I'm going to select this using Shift Alt, or first I need to vertices, so I'm going to select vertice mode, Shift Alt, and I'm going to right click here. Same with this. Well, before I do that, Control E, mark sharp. Same thing, Shift Alt, right click, mark sharp. And I'm just going to go around doing this for a bunch of edges, so I can mark all of this as a sharp. Okay, I could probably just do this. Alright, so far so good. That's how you do sharp edges manually, so just the edges that I marked will be sharp. So I'm going to go ahead and just use the edge angle for now, because that's sufficient for this tutorial. You want to position the hat in edit mode on top of the character's head so it fits nicely. And then what you can do is, to make sure that all of these, you want to make sure that in object mode the transforms, location, rotation, and scale are all normalized. So for that means location has to set all of these to 0, rotation all of these to 0, and the scale are all 1. And if that's not the case, what you can do is if you just hit spacebar and type in, let's see, apply. Let's see, you can apply object transform, and it'll automatically change all of these to normalize. So you don't have to really worry about rescaling or doing any of that. Now, what we're going to do for this hat is we're going to UV unwrap it, which will allow us to be able to texture the hat. So, let's just show UVs. Okay, so in order to texture this hat, we're going to need this 3D model to be put onto a 2D coordinate space, the UV coordinate space. So how do we do that? Well, you'll see that my hat is already UV'd because I already did that, but I will explain UVing very quickly. The basic process involves marking seams, which are sort of like places you cut clothes, to unwrap the clothing and put it onto a 2D coordinate space. So for instance, this hat is mostly a cylindrical object, so what I'm going to do is, let's just take portions of these and hide these portions, so I can just show you what really the main basis of this hat looks like. So it's like a cylinder, really. So really what I can do is I can just mark certain portions of this as seams. So like here, I can mark this as a seam. And then around the edge, from the back, let's say, I can mark this as a seam. Okay. So now you'll see when I unwrap it what it looks like. Let's just mark this too. So it creates this unwrapping of what I want. And you can go ahead and edit this to your liking. So you'll notice before, this is my actual unwrapped model. So if I go back, if I just undo all of this, you'll notice that my actual unwrapped model is like a square. And how did I do this? Well, back when I unwrapped it the original way, you can select certain vertices, like for instance here, press W on the UV space, and you can align them. So basically for each one, I selected the row, and I aligned it to X, etc. And you can keep doing that. Align to X, this one you align to X, etc., etc., etc. And then the same for across horizontally, you can align them in the Y direction. And this is used so that I can create stripes very easily. I won't have to mess around too much with Photoshop because I'll have all straight edges. So I'll show you. I'll bring in the texture in a little bit here. But before I do that, I'm going to explain baking. So what we're going to do is we're going to bake this model, and what that does is it makes pre-rendered shadows. So go ahead and create in the UV screen a new image. Make it like normally you want the texture to be 4 times larger than the finalized texture size, but that might be a little bit large. Let's just do 2 times, because our final texture size is going to be 512 by 512. That's what the importer accepts in terms of size. So go ahead and set it to 1024 by 1024. Hit OK. It'll make sure it's black, and you'll see this. Now, go over to the World tab right here. Make sure this check mark for ambient occlusion is on, so check that on. Go down to the Gather subheading, click Approximate. Check this Pixel Cache button, slide the correction to 1, and change the error to 0.25. So once your Blender World tab looks like this, you can go over to the Render tab, scroll down to the Bake subheading, make sure this bake mode says ambient occlusion. You can check normalized, and change this margin here to about 8. Okay? And then you can hit bake and you'll see what happens. So this goes ahead and basically pre-renders a shadow onto here. So my computer is sounding like a fan right now, because so now you get a pretty looking pre-rendered shadow thing. Looks like this. And if you click over here and you click over here and you click textured shading, you'll see that it actually is showing how it's shaded. Okay, so this is the ambient occlusion, or the bake, is what we're going to use to texture as a base for our texturing. So you can go ahead and save this image, save as image, and go ahead and save this as just Targa. You want a TGA file, so save it as for instance AO bake. Okay, save that. And then, in the UVs screen, we want to export the UV layout. And this can be a PNG. So, we'll call it UV layout.png. Okay, so now if you minimize Blender, go into your other folder, you can open up this AO bake, and this is what we're going to be using to texture. So, as with my other tutorial, we're going to call this AO, change this layer to multiply, and this will be at the very top. Or actually, the UV will be at the very top. So you can bring this in, copy this on top, and also change this to multiply. So this will be our guide. This won't be in the final texture. This will be actually deleted in the final texture, but this is just so we can see where our UVs are actually aligned. And so everything else will come underneath this, and this is where our texture magic happens. So, for instance, like let's say I just color this like an orangish beige color, for instance. Okay, so because it's like multiplied, it looks sort of like this. And if I want stripes, I can use my UV layout as a guide. So for instance, I can zoom in here, and then I can do this pretty easily. You know, for instance, like that. Let's just say that one stripe. Okay, I won't go through and do it all, but let's just say we save this and save this as a .tga file, and name it what you want your texture to be colored. So let's call it Blender tutorial _ Okay, save it as 32-bit. And then in Blender, go ahead, go into edit mode, and in the UV space, select image, open image, and choose our Blender tutorial _ color.tga. And now you'll see that it's colored in the way that we want it. And so, as I was mentioning here, this stripe, it aligns basically perfectly, since I have my UV layouts straight and flat like that. Now, I already made a texture for this, so I'm going to go ahead and open up the one that I actually already made. So it'll be here. Where is it? Here we go. Oh, whoops, I didn't do it in edit mode. My mistake. Let's do it again. Okay, so you'll see here that this is the finished texture of my hat. And you'll notice that it's not team colored, and there's a reason for this. I actually enabled paint for this hat in game so that these darker colored stripes will actually be team colored. I won't explain paint in this tutorial, but I will in a future paint tutorial, which will be specific for painting. But for now, let's just assume that this is just a regular old team-colored hat with that can't be painted. So now what we're going to do is we're going to assign this finished textured hat to a bone. So what that bone is going to be is it's going to be the BIP head bone. So now you can go ahead, select the engineer. You can delete him or hide him. So I'm going to go hide him by pressing the H key. Then the order of this is important. First, select the hat by right-clicking, and then shift-select the rig. Now press Control-P and click with empty groups. Okay? Now that we've done that, select your hat, go into edit mode, go over to the Object Data tab, and find the bone that's BIP head. So let's see if we can find it here. So BIP head. So now we're just going to make sure that this weight says 1 and click Assign. So now if we select it, it should select that. Any other bone we use shouldn't select unless it's that which I used for my other. I actually used this bone for my finished hat, so don't actually worry about this. This is not the one you should use. You should use BIP head. So we're going to actually remove that. So let's see. It's a good thing I checked that. Okay, so just BIP head is selected. So now go back into Object mode, go into the Object tab, and name this something that will be our SMD file name. So I'm going to call this Blender hat. Okay. So now, when we go to File, Export, SMD, with this selected, so make sure that only your hat is selected, File, Export, SMD, we can click blenderhat.smd. It'll ask us where in the folder we want to save this in, so I'm going to do my tutorial folder, export that, and you'll notice that in the tutorial folder I'll now have a new blender_hat.smd file. Now, the main difference between this tutorial and the other one, or one of the main differences, sorry, is that this new beta importer requires LOD models, and what LOD stands for is level of detail. So in-game, I'll have a quick explanation of this, is in-game, if you make a hat that's, let's say, 3,000 polygons, which is really high, and the character that it's on is very far away on your screen, why should we have to render all of those polygons when you can only see like maybe 2 pixels of it on your screen? And the answer is we shouldn't. We should only render a small fraction of that. So what we use is level of detail models, and they're basically like less detailed versions of our model that we used in replacement of our more detailed model when we get farther and farther away. So for instance, I'm going to show you a quick level of detail model that I made for the engineer. And you can so basically in the importer you have to have at least one model, but it can be 700 polygons at most. If you want to go more than that, then you're required to have at least one LOD model that brings it down to 700. So the maximum you can have is 1400 tries. So for instance here, if I check this hat, I triangulate it, I look up here, it'll tell me how many faces I have. So for instance, this is 876 triangles. Okay, that's too much. That's over the limit for 700. So I can't use this as my final model. I'm going to need at least one level of detail model to go along with this. So what I did is I created a level of detail for this, which is here. It's basically like a less detailed version. You can see that it looks much more jaggedy it's only it's actually exactly 700 polygons, so this is exactly on the limit. And you'll notice that, look, if I go out far enough, it looks exactly the same as my highly detailed version far away. You see? So there's no need to render whatever however many polygons if you get the same effect from both distances. So I'm going to close out of this and this one too. And the easiest way to make a level of detail model is to go ahead, remove faces that can't be seen normally. So for instance, from far away you're not going to be able to see these underfaces, so you can go ahead and remove those by selecting them, pressing X, delete the faces. Same thing with let's say these. So let's grab this. See, I won't be able to see these, so I can go ahead and hide these ones, or delete them, sorry. Alright, and then looks like I am still over the limit by a lot, so I'm going to go ahead and start deleting edge loops. And so what edge loops are they're basically like little like cross sections of that form a complete loop. So let's say this is an edge loop, and you select edge loops by pressing Alt right click. So see how it selected the entire loop here. So I'm going to go ahead and hide this for now so we can see things better. So it selected the entire loop. Same thing with this one, etc. And it even selects loops like this. Well, I guess it's not an entire loop. Well, actually it is. Is it? No, it's not. Well, I don't know that the formal definition is, but for our purposes, let's go with deleting a full loop and then having it automatically modify the model so that it connects to the next loop. So for instance, if I go ahead and Alt right click, select this edge loop, press X, and go down here to edge loop, it'll delete that edge loop, and you see how it automatically connects it to the next part of the model. So I can keep doing this for multiple edge loops. Alright, maybe for here too. And then, if I triangulate this, it'll say 716, so maybe like one more or something. Maybe around here even, I could just get rid of this one. Okay, so let's see, boom, 700 exactly. Okay, I think that's exactly what I did for my last hat too. So now you'll see that maybe your UVs are kind of messed up because we changed some things. So you can go in here and you can actually fix the UVs by just doing some welding maybe. So you can maybe select these, weld the, or whoops, auto align, and you can auto align these, maybe auto align these. Same with this. It'll look a little bit better. Alright. So this is our level of detail model, and you're going to export it the exact same way as before. Since we already have it rigged to the skeleton, this bone rig, we don't have to re-rig it. But what we need to do is we need to name this something differently. So make sure select this in object mode, go to the object tab, and change this name to like underscore LOD or something like that. Okay? And then same deal. Go export source engine.smd. So export that, and you'll see now that we'll have two SMD files. These are both our model files. This is our high-level detail one, and this is our low-level detail one. Okay? So now, the last part is basically compiling this thing. So this is the main difference that we're going to. This is actually the most important part of this tutorial, is going over the new method of compiling. So now that we have everything ready to go, let's see if we have everything ready to go. So we have our texture, we have our two models, and that's all we need to compile for the. You also need a backpack icon, and I'll explain in a future tutorial how to get good-looking backpack icons. But for now, I will just quickly go over how to create a backpack icon. What it needs to be is it needs to be a 512 by 512 icon. Your hat needs to be centered, but it needs to be centered not as big as it can be. It needs to be centered in a 512 by 320 or 512 by 328 box. So if it can fit inside this, then you're good. If it clips outside, it will not work. Okay, so it needs to fit inside that box. So something like whatever 328 pixels or whatever it is, it needs to fit inside here. And make sure that this background is completely black, 100% black, or it won't work. And in your channels tab, you need to make everything but your hat black. So your hat needs to be white, everything else needs to be black. Once you have that, save this as a .tga file and name it something like backpack.tga or whatever you want. Okay. So we can go ahead and close out of this. We don't need these anymore. All right. Okay. So go ahead and open up TF2. Okay. Okay, now go to the workshop. Click Publish New Item. Here you will. This is the image that you will be using as the main workshop image. So basically, when people are browsing the workshop, this is the image that they'll see first. And the best way to make these is using the source filmmaker, and I'll make maybe a tutorial on how to get good-looking renders out of source filmmaker with your hat or miscellaneous item or whatever. This title is the main workshop title, and the description is what they see in the description, obviously. So go ahead and we can leave these blank for now. In this file subheading, click Import Beta. Name this whatever you want. This won't be shown publicly. This is just the client side compiling name. So we'll call it like Blender Tutorial. Okay. So here it's a hat, and it fits in the hat regions, and it's for the engineer. So click Engineer, and it's a hat. So in our high LOD, our level of detail, the high one is the highest and most detailed model. So go to where we saved this. Actually, for our purposes, I'm not going to use the one we just made because, or maybe, well, actually, well, we could use it. Let's just see what happens. So Blender hat, okay. It'll give you how many triangles it is. So it is 876 triangles, and then for our medium one, we click the LOD. Okay, so that's all we need. We don't need to use a low one unless this one isn't already lower than 700. Remember, the high LOD you can make up to 1400 triangles. The medium one you can make up to 1000, and the low one you can make up to 700. Okay, as long as you have 700, it doesn't matter. Even if your high one is 700, then you don't need to make any level of detail models. So I guess if you can make a quality looking model that's only 700 triangles, then you don't need to make any LODs at all. And up here, the backpack icon, choose what we made, the backpack.tga. If it worked properly, it'll show you a preview. Because remember, it's got to be in that 512 by 328 width. Set up with the black background, and the alpha channel has to be white where the part of your hat is being shown. And finally, over here is where you have the skin section, and this is where we can choose to make the skin of the hat an all team texture or a specific team. So I'm going to go ahead and choose specific team since I'm making this a team colored hat. And you'll see it gives me two options, red input and blue input. So each one of these will correspond to a different skin, red and blue, obviously. And since my hat's going to be painted, I'm going to choose this option down here called Paint VMT. So go ahead and select red input, this little icon right there. You'll notice it takes you to this screen that says Edit VMT1, and over here on the top left you can choose between the blue and red textures. So for paint, you use the same base texture for each one, and you just use different color codes down here. So I won't go into too much detail since I'm going to make a later tutorial about paint, but I'm going to go ahead and open up my base texture. And remember, the texture size has to be 512 by 512. So when you're done with your large texture in Photoshop, you want to size that down back to 512 by 512. So over here, I'm going to select this, going to go to the blue tab, select the same thing. Your light warp is going to be pyro. All of these options correspond to different things. Most of them are explained on the Valve developer wiki. I guess the important ones to talk about are the Phong boost and the rim light boost. So the Phong boost is essentially how bright your model is going to be, and the higher this number, the brighter your model. The rim light boost is how bright the rim lighting is going to be. So that's like the lighting around the model. So you can leave all these alone. We don't have to really deal with any of this. Most of the time, defaults are okay unless you're looking to make specific things, like for example a self-illuminated like light or something, or whatnot. So here I'm going to enter in like some values that make this red. These aren't the values I actually ended up using, but they'll make a red color just for purposes so that we can compare later. So basically, this is just the paint part. So once I enter in these, I can hit OK, and now we have all the components. We have our model. We selected the information about it. We had a name. We have the backpack icon and the two skins, or which are the textures. So unless you want to make a custom QC, don't choose this. Just go ahead and click preview to see if it worked. If it worked properly, we should get a preview of our hat. So here we go. And we can move this guy around, see basically how it looks like. Two different skins. So here's blue, here's red, and we can choose different paint colors just to see how it looks like. And you can change the lighting by holding Control and moving the mouse around, the left mouse button. And another important thing is you can also check to see the LODs. So here's the first level of detail. You see it's more or less like fully detailed. And if we go down here and choose LOD 1, we can see we have our 700 triangle version, the lower polygon text model. So you'll notice that, let's just choose LOD 0. We'll pull this guy out a bit. Okay, so let's just say he's like way far out here. Okay, can you tell the difference between LOD 0 and LOD 1? No, it's pretty much impossible. So that's exactly the reason I was mentioning before why we use LODs. And another thing you can do here is have them use a different weapon, have them do different things like run around, or look at the effect when it's ubered, or Girardi'd, or burning, stuff like that. And when you're satisfied with how your hat looks, you can go ahead and hit OK, and if not, also hit OK. You can go back and change some of these things. So now we're going to go ahead and hit verify. And what verify does, it goes and runs a check that basically sees if everything is in place, if you have a backpack icon, all that stuff. If you hit verify and it doesn't give you any error messages, then you successfully pass the verification test, and this finish button will highlight. So if you go ahead and click this button, it'll compile a zip file that's set up in sort of the Valve's preferred file structure, and that's what you will be using essentially to submit to the workshop. And this is important because the new file system that they have set up gives you a little gold star on the workshop page, which I'll show you in a second. And this gold star basically certifies the compatibility with the new beta import tool, and this allows Valve to really easily implement your model into the game. So anything that's gold starred will allow you to have a better chance of getting your items into the game. So I hit finish, and you'll see it gives me this little dialog that says work complete. Your item has been saved as this zip file and is ready to upload. So you hit OK. You name this whatever you want. So this title will actually be public. So this is what people will see when they browse the workshop. So you say like totally the best hat ever, and you describe it. You say, wow, I really like hats. And then this preview image has to be 512 by 512, and again, the best way of making preview images with the source filmmaker. And then you're ready to go. The last thing, make sure that in the tags you have the class it's for and what type of thing it is. So headgear, you'd want to choose that. And you'd go ahead and click submit. I'm not going to submit this because I already have my finished product up on the workshop, but this basically will submit something that looks sort of like this to the workshop. you'll have a little uh, entry in it into your TF2 workshop file, and if you click View, it'll take you to the workshop page of how it looks like. Oops. So this is my finished entry. It's called the conductor's cap, and if you found this tutorial useful, you can always rate this up or not. It does kind of feel good when people give me feedback on some of my workshop files. But down here, as I was mentioning, is this gold star thing. So it's certified compatible, which means that if you have this gold star, it makes it way easier for Valve to implement your item, and it makes you have a much higher chance of getting into the game. So this new beta import tool will allow you to get this certified compatibility thing on your workshop entries. So that's basically the end of the tutorial. If you have any questions or anything, there will be a Steam guide that I'm making of this, which will have sort of like a picture-based supplementary overview of what I just went over for the past, I don't know, 45 minutes or so. And it'll also have a frequently asked questions section, just like my last tutorial. And again, I have a Steam group called the Blender Tutorial Community, and it's very useful for people who are looking to ask questions or post some of their work in progress pictures and stuff like that. So people in this group, they just ask questions, like for instance here, this person asking me a question, and I reply as best as I can, and at the end hopefully their problem got solved. So yeah, here, like, oh shit, I got it, thank you, blah blah blah. So it allows me to just communicate with you through this Steam group, and I'll be posting my Steam guide here as well, and any announcements in the future. And remember, if you ever need access to my old tutorial, you can always find it on my Steam profile. Just go to my Steam profile and go to Guides, and it should be right here. So it's the old one in case you ever need to refer back to it and see how we used to compile old school, I guess. So yeah, that's basically it. My previous tutorial helped no joke, like thousands of people, and there had been some people who actually had almost no experience with Blender at all, or even no experience, and now have more than 20 items in the game, and that just goes to show you that it's possible to do something as long as you set your mind to it. And so yeah, those people are very thankful, and it's always a pleasure to help the community out and help these people out. And so again, if you have any questions, I'd be glad to answer them when I have time. Lately, I've been getting bogged down in work as I proceed more and more, almost done with my undergraduate career, and I imagine that once that's over, I probably won't have any time at all. But in the meantime, happy modeling, and thank you for listening to this tutorial.